Today we're going to work with square roots a little bit. I'm going to show you how to simplify a square root, or how to write it in simplest radical form. Think of a fraction. If we had the fraction 4 over 8, we would reduce that to 1/2. It wouldn't be appropriate to leave it as 4 over 8. Same thing with square roots. You can reduce those so they're in simplest form. Let's begin with a little bit of vocabulary. The purple guy here is known as a radical. The number underneath the radical is known as the radicand. And the number out front we call the coefficient. The process for simplifying square roots is actually fairly simple. It does take a little bit of practice, but after some practice you'll be really good at it. Let's take a look at an example. Here we want to simplify the square root of 8. We always begin by writing a list of the perfect squares. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, etc. So we have this nice list to work with. Now let's take a look. In the radicand, we have an 8. The 8 would be right here on my list, but it's not in that list. It's not a perfect square. So what we do is we work down the list from biggest to smallest to find the biggest perfect square that goes into 8 evenly. 4 goes into 8 2 times. 4 times 2. So what we'll do is we'll change the square root of 8 to the square root of 4 and the square root of 2. Now we have a perfect square and a non-perfect square. The perfect square will simplify nicely because the square root of 4 is 2. The square root of 2 is nothing special, so that just stays as the square root of 2. So that leaves me with 2 times the square root of 2, or 2 square roots of 2. So the square root of 8 is equal to 2 square roots of 2. You can check that in your calculator. If you type in the square root of 8, it'll give you a number, it'll be a decimal. And you type in 2 times the square root of 2, you should get the same decimal in both cases. Now, what if there was a coefficient there? Well, example 2 deals with just that. Here we have 3 times the square root of 8. And once again, 8 would be right here. The biggest number on this list that goes into 8 evenly is 4. Square root of 4 and square root of 2. That's the same thing we did over here. Only difference is now I have this 3 out front, and I just bring the 3 right down with me. Square root of 4 is 2, so I have 3 times 2. The 3 just followed us right along on the outside. 3 times 2 is 6, so 6 square roots of 2 is in simplest radical form. 3 square roots of 8 and 6 square roots of 2 really have the same value. On example number 3, we have the square root of 32. Again, I generate my list of perfect squares. Always generate that list. Now 32 would be right here, but it's not in the list. And so I'm going to go down from biggest to smallest to find the largest one that goes into that. 25 does not go into 32 evenly. 16 does, however. 16 times 2. And so what I'm going to do is break this 32 apart into the square root of 16 and the square root of 2. Square root of 16 is 4, and the square root of 2 is just the square root of 2. Notice that this 4 is not in a square root. Once you take the square root of the perfect square, the square root is used. You only use that radical one time. So 4 square roots of 2 is equivalent to the square root of 32. Example 4 is the same thing, except this time it has a coefficient. We still have the square root of 32, 16 square roots of 2, 4 square roots of 2. It's exactly what we had over here. The only difference, we have that -5 out front. -5 times 4 is -20. So -5 square roots of 32 in simplest radical form is -20 square roots of 2. The best thing to do at this point is to practice. There's several more examples. There's 5 more of them. I'm going to ask you to pause the video here and try some of those examples. Let's see how you do on those. Let's take a look at the answers. Number 5, we have negative 3 square roots of 18. 18 would be right here on my list. I'll go down. 16 doesn't go into it, but 9 does twice. 9 times 2. So I have a square root of 9 and a square root of 2. This 3 out front, the coefficient, just comes down along for the ride. Square root of 9 is 3. Square root of 2 is the square root of 2. It's nothing special. Negative 3 times 3 is negative 9, square roots of 2. Number 6, we have negative 3/4 times the square root of 96. Let's simplify that square root of 96. 96 would be up here on our list, but it's not there. Does 81 go into it? No. 64? No. 49? No. 36? No. 25? No. I'm starting to lose hope. 16 does. 16 goes into it 6 times. 16 is the biggest one. So, 16 and 6, square root of 16, square root of 6. Now the square root of 16 is 4, square root of 6 just comes down. And so does that negative 3/4. Negative 3/4 times 4 is negative 3, square roots of 6. Example number 7, we have 2 square roots of 98. 98 would be up here on our list, but it's not there. Does 81 go into it? No. 64? No. 49 does. 49 goes in twice. So we have 49 times 2. We'll change this 98 to a 49 and a 2. Square root of 49 is 7. Square roots of 2. And we can't forget we had this coefficient out here. So we have 2 times 7, 14, square roots of 2. Finally, number 8 and number 9, those are actually very simple. Square root of 36, well, that's on our list. Square root of 36 is 6. 1/3 of 6 is 2. Number 9, here's the trick to number 9. If you have a fraction inside a square root, you can actually just break it in half. Square root of 25, square root of 81. That's 5 over 9. And that's how you can simplify square roots to write something in simplest radical form.